Hello students, good afternoon. Welcome to the chemistry class and welcome to the second part of the chapter surface chemistry. In this class we will discuss about the catalysis. So what is the catalysis? So as we know that catalysts are those substances which alter the rate of the reaction. Means they can increase or decrease or can stop the reaction are known as catalysts. Okay, so the substance which alters the rate of chemical reaction which being used up in the reaction is called as catalyst, and the phenomena is termed as catalysis. So classification of catalysis: so positive catalysis. So when catalyst increases the rate of reaction, known as positive catalysis. For example, oxidation of ammonia. In this, platinum catalyst will act as a positive catalyst because it will increase the formation of ammonia. Okay, and other processes are also given here. 2SO2 plus O2 gives 2SO3. In this case, V2O5 catalyst will work as a increasing the formation of sulfur trioxide. Like this, MnO2 also act as a positive catalyst. Negative catalyst: when the catalyst decreases the rate of reaction are known as negative catalyst. So the oxidation of chloroform by air is retarded in the presence of ethyl alcohol, and hence ethyl alcohol act as a negative catalysis. Okay, now catalytic promoters are poisons. So the substances which increases the activity of catalysis are known as the catalytic promoters, and the substances which reduce the activity of catalyst are known as the catalytic poison. For example, N2 plus 3H2 gives 2NH3. So in this case, Fe plus MO. Fe is a catalyst, but MO is a catalytic promoter because it increases the rate of the reaction of the catalyst iron. Okay, now types of catalysis. So there are two types: homogeneous and heterogeneous. So first one is homogeneous catalysis. So when the catalyst mixes homogeneously with the reactant to form a single phase, it is said to be a homogeneous catalysis. Means when all the reactant and products are present in same phase, then this type of catalysis are known as reactant, product and catalyst all are present in same phase are known as homogeneous catalysis. For example, in this case you can see here that 2SO2 plus O2 gives 2SO3. In this reaction, NO is a catalyst. So you can see here that all the reactants are present in gaseous state. So this reaction is known as homogeneous catalysis. Okay, other examples are also given here. Here all the reactant, product and catalyst are present in liquid state, and other example in which also there is a liquid state. Okay, so it is known as the homogeneous catalysis. Next one is heterogeneous catalysis. So in heterogeneous catalysis, what will happen when all the reactant, product and catalysts are not present in same phase? Means the reactant will be in other phase and product will be in other phase. For example, manufacturing of ammonia. So you can watch here N2, H2 and NH3. These are in gaseous state, but the catalyst used in this reaction, that is iron, and that is solid. So you can see here that the reactant and product and catalyst are not in same phase. So it is an example of heterogeneous catalysis. Other, oxidation of sulfur. Here also in case of gaseous there is a solid catalyst will be present. Okay, so there are many other examples are given here. Now come to the theory of heterogeneous catalysis. So adsorption theory: the mechanism of heterogeneous catalysis can be understood with the help of adsorption theory. So according to this theory, heterogeneous catalysis is a surface phenomena and involve the chemisorption of the reacting gases on the surface of the solid catalyst. The solid catalyst provides a number of free valencies at its surface through which chemisorption of gases on the surface takes place. Okay, so according to the adsorption theory, the heterogeneously catalyzed reaction usually involves the following steps: chemisorption of reactant on the surface. So firstly, that is a reactant molecule and that is the catalyst. It will go to the catalyst surface and attach to the bond. Okay, so it is known as the chemisorption, and after that it will perform its function and finally it will get removed. Activity: the ability of catalyst to accelerate chemical reaction is termed as a activity. Catalyst can increase the rate of chemical reaction to great extent. In some cases, the degree of acceleration can be as high as 10 to the power 10 times. For example, mixture of pure H2 and O2 does not react at all in absence of catalyst. So the reaction between reaction between two to form water is a catalyzed by platinum. So it is known as the activity of the catalyst. Selectivity: so as we know that for a particular reaction there will be a particular type of catalyst required. So it is known as the basically selectivity of the catalysis. So the ability of catalyst to direct a chemical reaction to yield particular product is termed as a selectivity. For example, illustrate the selectivity of solid catalysis. So on heating ethyl alcohol in presence of copper as a catalyst, it undergoes a dehydration to give a acetaldehyde. On the other hand, when heated in the presence of aluminum as a catalyst, it undergoes dehydration to ethine. So here you can see there are two catalysts. So this catalyst will dehydrate this compound and gives acetaldehyde, but this catalyst on same reactant after the removal of water gives ethine. So we can see for a particular type of reaction there will be a particular type of the catalyst. So it is known as the selectivity of the catalyst. Okay. Now come to the enzyme catalysis. So enzyme catalysis means enzymes may be defined as an important class of globular proteins which act as a biocatalyst in living system are known as the enzyme catalysis. Okay. So there are many enzymes which act as a catalysis reaction catalyze. Invertase enzyme converts sucrose into glucose and fructose, amylose starch into N-glucose, maltose into glucose, lactose into glucose and galactose. So these are the enzymes which are used in the biological system. Okay. So characteristics of enzyme catalysis: number 1 is specificity. Enzymes are highly specific in nature, specific in their action on the substrate. Each enzyme catalyzes only a specific type of reaction. For example, the enzyme urease hydrolyzes urea to ammonia and CO2, but it does not hydrolyze N-methylurea. Okay, so urea hydrolyzed to urea in presence of urease to give ammonia and water, but in case of N-methylurea this cannot. So because it is an mineral compound, organic compound, but it is an bioorganic compound, so it will be hydrolyzed by this enzyme, but it will not. So catalytic efficiency: so enzymes are highly efficient catalysts. They speed up reaction up to 10 million times as compared to the uncatalyzed reaction. Okay, means in presence of catalyst the reaction will faster, the rate of reaction will be faster 10 million times more. Okay, very small quantity is sufficient to catalyze a reaction. As we know that there is very small quantities sufficient to catalyze the reaction to increase the or decrease the rate of the reaction. Optimum temperature and pH: the catalytic activity of an enzyme is maximum at a particular temperature and pH. So the optimum temperature at which the activity of enzyme is maximum is about 37 degrees centigrade. Below this temperature the enzyme catalytic reactions are slow, and above this temperature enzyme gets denatured and lose their activity. Enzyme inhibitors: so the action of enzyme are controlled by various mechanisms and they are very sensitive to inhibitors. Catalytic poison: various inorganic or inorganic substances such as HCN, H2S, CS2, etc. act as inhibitors for enzyme. In the presence of these substances, enzymes lose their activity. Okay. So mechanism of enzyme catalysis. So mechanism of enzyme catalysis not very well understood in 19 1894, Fisher suggested lock and key mechanism to explain the working of enzyme as catalyst. According to the lock and key mechanism, step 1, binding of enzyme to substrate to form an enzyme substrate complex. Okay, enzyme substrate complex. And step 2, enzyme substrate complex are combined with product and formation of the product. Okay, and release of the product from the enzyme, and finally product will form after the removal of the enzymes. Okay, thank you, have a nice day.